So we'll now see how to find the shortest distance between a line and a curve. So given a curve y equal to some f of x and given some line ax plus by plus some c equal to 0, how do you find the shortest distance between the curve and the line? So for this, what we need to do, let's say, for example, you choose a point P on the curve. Then for shortest distance, you draw the tangent at P that should be parallel to the line. So for shortest distance, what are the criteria? The tangent at P is parallel to the line. So line is already given, point is not given. So what we'll do, assume a random point called x1, y1 on the curve. Then the derivative at that point, so dy by dx at P, x1, y1. So you are going to equate that with a slope of the line because they're parallel. And you know that for f of x, the derivative at this point is f dash x1. So this derivative is nothing but f dash of x1 equal to minus a by b. This is condition 1. And the second condition is since x1, y1 lies on the curve, x1, y1 will satisfy the curve. So we have y1 is equal to f of x1 is the second condition. Then you just need to solve 1 and 2 to get p x1, y1. So basically when you solve them, you'll get the value of x1 and y1. And once you know the point P, then you can find the distance from P to this by distance formula. So then what is the distance PM? Mod of ax1 plus by1 plus c by root of a square plus b square. So this is how you can find shortest distance between a line and a curve. Choose any random point. First, find the coordinates of that by using the condition that the tangent at the point is parallel to this for shortest distance. Then, after equating slopes, we got one equation. Substituting x1, y1 in the curve, we got one more equation. Solving them will give you the coordinates of P. And once you know the point P, distance from point to a line, you already learned the formula. You can use that and find the shortest. So the curve can be anything, like it can be a circle and a line, parabola and a line, ellipse and a line. This is like a general method you can use for conic sections also. If you want to mention here, you can mention P x1, y1 lies on the curve. That's why we wrote this condition. So this was between a line and a point, basically a line and a curve. Now we'll write shortest distance between two curves. Shortest distance between two curves. So let's say we have two random curves. One is y equal to f of x and say the other is y equal to some g of x. And you want to find the shortest distance between them. So usually the shortest distance between two curves is always along a common normal. So if I take a point P here and draw a tangent, then along this you draw a normal to the curve, first curve. Wherever it meets this, you again draw a tangent to the second curve. So PQ is a common normal and that is the shortest distance. So PQ is the shortest distance. So the shortest distance is always along a common normal. So you can write shortest distance is always along the common normal. Is always along the common normal. So what we need to do here is, if you can find the coordinates of P and Q, the problem will be done. You can find the distance. So to find the coordinates, what we do is, sometimes if they give you a parabola and all, we'll take parametric coordinates. But since I'm not taking parabola, I'm doing in general, I'll assume something. So assume some coordinates for P as some x1, y1. Assume some coordinates for Q as x2, comma, y2. Then, so the criteria that you can use is the tangent at P and the tangent at Q for both are parallel. So the derivative at P for the first one, f dash of x1, and the derivative at Q for the second one, that is g dash of x2 are equal. So this is first condition that you can write. And basically you have to find the coordinates. So if this will not work, maybe this will give some condition which can not give you all the required values. So find normal at P x1, y1 to first curve and call it as equation 2. So usually if the slope is not giving you the answer, then you need to do this. Then find the normal at q to the second curve. Normally q to y equal to g of x. And these two represent same line. So compare 2 and 3. 2 and 3 to get P and Q coordinates. So to get the coordinates of P and Q, to get P and Q coordinates, and then use distance formula. But this is general method. Otherwise, if it's a parabola and all, you can do it in a much easier way. And then use distance formula. This is in general. But let's say I call it as case 1. So let's say I have some circle and some parabola. And I want to find the shortest distance. So you know that in the case of a circle, the normal will pass through center. So the normal passes through center and cuts the parabola somewhere here. So the parabola will be given to you. Like for example, you are given a parabola y equal to x square minus 1. Circle also will be given to you. Let's say for example, the circle is x square plus y square minus 6x plus some 8y equal to some 0. So randomly I'm choosing. So if you have to find the shortest distance, what you need to do is you choose any random point P. How to choose in parametric form? If you assume x as t, y will be t square minus 1. The number of variables are reduced. Like earlier, I had to choose x1, y1, x2, y2. I have 4 unknowns. But here, instead of 2 variables, I got only 1 variable in 1 point. And the other case, if you know the circle, you know the center. What is the center? Minus g minus f. So here g is minus 3. F is 8 because 2gx, 2fy you compare, g is minus 3, f is 4. You know the center is minus g minus f, 3 comma minus 4. So then what you need to do is write down the normal at P to the parabola. How will you write the normal at P? For the parabola, you find the derivative dy by dx, you will get 2x. This is for parabola. So for the parabola, find the derivative dy by dx, you will get the answer as 2x. And you find the derivative at P point, which is t comma t square minus 1. This value becomes 2t. And once you know the slope of the tangent, you will know the normal slope. This is small m tangent slope. So what is the normal slope? Minus 1 by 2t. And since you know this point and you know that m is the normal slope, you can find the normal equation. So you can write down the normal at P equation. Normal at P t comma t square minus 1 is y minus y1 equal to slope we got just now minus 1 by t to x minus x1. And once you got this, what is the condition you can use? This normal passes through center of the circle. So it passes through the center of circle. This condition you can use to find the t point, t value. So it passes through the center 3 minus 4. So substitute 3 minus 4 in this, then this will become minus 4 minus t square plus 1 equal to minus 1 by t into 3 minus t. So just cross multiply, you get t into minus 3 minus t square equal to minus 3 plus t. So this will give you an equation in t, solve for t. So let us write down the equation minus 3t minus t cube equal to minus 3 plus t or t cube plus 4t minus 3 equal to 0. So you just solve for t here. And once you get the value of t, you will know the point P. Then suppose if this point is Q, CQ is the radius of circle, which you can find with the formula root of g square plus f square minus c. Root of g square plus f square minus c. So that is root of 9 plus 16. C is not there. 0. Root 25, 5. You know that. So from CP, you subtract radius, you will get PQ. So the shortest distance PQ can be written as the distance from center to the point P, which you have already found, minus the radius. So what is P? T comma t square minus 1. And the radius you already got for the circle. So just you have to find this distance and subtract R, you will be getting the shortest distance. And to find the distance CP, you have to know P coordinate because center is already known. What is the center? We already wrote 3 comma minus 4. Value of t, how did we get that? You just solve this. T cube plus 4t minus 3 equal to 0. Gives value of t. So with this, you find the value of t. So what value will satisfy this? If it has real roots only, it is possible. I gave it randomly, so it may or may not have real roots. So gives a value of t which is real. If it doesn't have real roots, then you can't find shortest distance. Such a point will not exist. Okay. And in case you get a real value of t, you can substitute here and do it. So write down the method. So I gave a random example, but we actually have problems already, which I copied onto the screen. So when we do that, we can come across these cases. So since I gave randomly, the value of t, you may get real or you may get imaginary. If you get real only, it is possible, otherwise not possible. But procedure will be the same. So write this method. Sometimes instead of giving circle and parabola, they may give two parabolas. Then the first method, which I gave comparing the parabolas method, you can use. And here x1, y1, x2, y2, four unknowns are there. But if you know the parabola, with parametric representation, you will get only two unknowns. Like you can choose parameter t1 for one parabola, t2 for another parabola while writing p and q. So you'll have only two unknowns in that case. So here we'll discuss this concept with the help of an example of parabola. Let's say we have a parabola of the form y square equal to 4 into x minus 3. And another parabola of the form x square equal to 4 into y minus 3. So clearly you observe when you interchange x and y in the first one, it will give the second one. So in that case, there will be symmetric about y equal to x. So interchanging x and y in one equation gives the other equation. So in such a case, we say there is a symmetry about y equal to x. So in such cases, we say there is symmetry about y equal to x. Gives the other equation. This is a condition for symmetry about y equal to x. So if you observe, how do you plot the curves? The first one is having y square, so it's a right-handed parabola. Vertex is at 3, 0. So you'll have Noel, actually it's a question of calculus only. Okay, it's not a question of coordinate. Okay. AOD only, if you don't think I'm doing parabola chapter. So there's a question from application of derivatives. So basically this is a parabola with vertex at 3, 0. And the other one is vertex at 0, 3, like this. So this parabola is y square equal to 4 into x minus 3, and this parabola is x square equal to 4 into y minus 3. So I just took the example of parabola, but they can give any two curves for this type of questions. Okay. And if you draw the straight line y equal to x, we know that the slope of this line is 1. This will make 45 degrees with the axis. So for shortest distance, the tangent at P is parallel to y equal to x, and there is a point here Q where the tangent is parallel to same line. So usually you can draw the common normal here. So PQ is the shortest distance. The common normal will give you shortest distance. PQ is the shortest distance between the curves. And if you have to find the shortest distance between the curve, first you can assume some coordinates for this point, some a comma b. And clearly you see there is symmetry about y equal to x, means we reflect AB about y equal to x, you will get b comma a. So this is BA. So by distance formula, this is root of a minus b whole square plus b minus a whole square. And because square is there, you can write 2 times a minus b whole square only. Because when you square, whether it is b minus a whole square or a minus b whole square, it is the same. So root 2 times mod of b minus a is the shortest distance. But how to find this AB? If you differentiate this parabola, you will actually get, if you differentiate this, 2y dy by dx equal to 4. So dy by dx is 2 by y. And you need the derivative at P. So this implies what is the derivative at the point P? A comma B, it is 2 by B. So this is parallel to y equal to x straight line. So you have to equate with 1. So 2 by B equal to 1 will give you B equal to 2. And once you know this, you know that A comma B lies on which parabola? It lies on y square equal to 4 into x minus 3. So therefore, if you substitute AB, you'll get B square equal to 4 into A minus 3. Then put B equal to 2, you'll get 4 equal to 4 into A minus 3. Or A minus 3 is equal to 1, A equal to 4. So once you get this A value as 4, so what is the point P? A comma B. So P is A comma B means 4 comma 2, and the point Q is 2 comma 4. The shortest distance is nothing but distance between these two. You can even substitute here. I derived a formula, but otherwise you can again apply distance formula and find a root of 4 minus 2 whole square plus again for root 8, that is 2 root 2. This is the shortest distance. So whenever you reflect any point about y equal to x, you'll always get the points interchange that I use directly here. Remember that. So reflection of AB about y equal to x is always B comma A. So Q will be the mirror image of P. That is the reason I took BA for this.